Alrighty. So how do we have the server actually communicate with the client? Basically, the general pattern that we're going to follow here is in our server.js, what I'm going to do is I'm going to attach on a event onto this IO. And just like the socket, the IO object is a event emitter. So it emits events, it can send events, and it can receive events. And that's really what we work with in Socket.io applications. So what I want to do is I want to say io.on connection socket goes into, and then I'm going to say console log client connected. And then hit Control S. Now I do have my server running over here on nodemon. And you'll see something interesting. The second I hit Control S on this code, we do see client connected. So why is that? Well, that's because I have my browser window open on the other hand side, and when it loses a connection to a Socket.io server, like what happened when we restarted the application, it will go into reconnect mode, and then it'll try to reconnect back to the same server. And so that's why we immediately got a client connected. But I can show you guys how that really looks if I come over here and hit F5 or hit the refresh button. Notice how client connected again. I can go ahead and I can remove our console logs because those are kind of actually we won't need them anymore at all, so I'll just completely nuke them entirely. In fact, you can also nuke the middleware as well. You don't need that anymore. That was just for testing purposes. Hit Control S, and now we see server connected on port 3000, client connected, and if I come over here and refresh, we get client connected as well. So that's what's going on here. Again, if I go over to the network tab, go over to WS, I can see the data that's being sent for the connection. Okay, so how do we go about receiving an event from the server? Well, this socket object that's passed into the io.connection event represents, it's the other side to the socket that the client receives. So this socket over here on the client is going to be basically the same object. Now, it's not really the same object. It's just the same concept. If I said something like socket.ble equals whoa over here, I wouldn't magically be able to access socket.ble over here. It's not the same object. There's no magical proxy stuff going on here, but it's the same concept. This socket, whenever a client connects, is going to be kind of, think of it as being connected to or tied to the other hand side. So when a socket connects, what we want to do is we want to add event handlers to it. So for example, I'll do Socket.on, and I'll say Socket.on chat::add, and then I'll say message goes into, and then I'll say console log, or how about data, console log data. So what I'm doing here is I'm saying, okay, whenever we get a socket incoming, go ahead and add this event handler. And the event handler is an arbitrary string. Now, there are special events, just like connection is a special event. Connection, for example, would be something that's passed in from the framework saying, hey, something connected. Other special events that would be here would be things like if it disconnected. So we can say something like socket on disconnected. And we can say console log socket disconnected. And we can do that. And then if I came over here and refreshed, or whoops, it's disconnect, isn't it? Come over here and refresh, we get client connected, client disconnected, then client connected. That happened because I refreshed the page. So we can add all these events. Now it's important to understand the really, really, really important concept here is what I have highlighted here. These socket.ons only apply to the socket that was connected to. So these socket.ons won't apply to every single socket. Well, in this case it will because we're performing this logic in the connection. But if I said something like if I don't know, env does equals debug, right? Then this socket.on isn't going to be invoked, so that event handler is not going to be there. I could also do something like if socket.address or whoops, it's not socket.address. It's actually something kind of silly. Socket.request.connection.remote address equals localhost, for example. Then I can do this, add this event handler. What I'm trying to say here is that the Socket.ons apply to just the current socket we're looking at. They don't apply to all of the sockets. So we can do custom authentication, say, hey, if you came from localhost or if you came from this IP address or whatever, then let's give you these special event hooks. Otherwise, let's not. That isn't as... It seems like a really handy feature in some circumstances, but it's not as handy as you'd think it would be. You generally always want to perform your own authentication every time you connect. Anyway, so the Socket.on chat::add, again, an arbitrary string. I could do whatever I wanted for this event name. It's just an arbitrary string. In this case, I chose chat::add. I like to prefix my events with the feature that we're referring to. So I'd have chat::add for adding a chat message, but I might have something like playlist::add for adding an item to a playlist, something like that. But now, whenever this is passed in from this code over here, this code on the server will be invoked, and we can prove that. I can come over here and I can say socket. Now I'm going to do the opposite of on. What is the opposite of on? Well, I guess you could say off, but that's really not what I was going for. In this case, the opposite of on is emit. So I'll say emit chat::add, and then I'll pass in an object with message equals ble. Hit Control S, server restarts. Now I'm going to come over here to the right-hand side, and I'm going to refresh the HTML page, and look at what happens over here. Message.ble gets printed out. And we can see in this, if we open up our WebSocket, we can see that the client, wow, that did not go how I intended it to go. We can see that the client actually didn't send that through the WebSocket. It actually sent it through one of the earlier handshakes because of the way Socket.io works. But the point is that it did send that message out to the server. You would see it through the WebSocket if I did something like window.setTimeout. I just want to prove to you all that I'm not crazy. Let's say 2 seconds. So after 2 seconds, we'll set in chat.add. So I'm going to come over here, refresh, bring back over the window. And if I went in here to our WS, clicked on this, went to frames, notice how that's what's sent. The number 42 followed by an array with the name of the event, in this case chat::add, and then followed by the parameters, all formatted into JSON. All right, so that's pretty exciting. Let's go ahead with this knowledge. With this knowledge now that we know that Socket.emit is kind of the opposite from Socket.on. So anything from Socket.emit on the client side will be handled by the corresponding handler on Socket.on. With that knowledge, let's go ahead and build up our chat form so that we can do that. So let's go ahead and expand this so we have a little bit more space to work with. And I'm going to open up my index.jade here and then collapse that. And let's go ahead and actually write our logic that will have our chat box actually emit those messages. So what I'm going to do is I'm going to say const chat input equals document dot query selector, not query selector all, just normal query selector, chat-form input type equals text. So with that, that query selector, we are going to get a reference to this element in our HTML page. And then I'm going to say chat input dot add event listener key press event goes into, and then I'm going to say if event dot key code equals or does not equal 13, then return. What I'm doing here is I want to be able, for the chat box, you can press the keys obviously and they'll show up on the input, but when they hit enter is when I want to actually send that message. So that's what this code does right here. It says if they did not press enter, just go ahead and bail out of this handler because we have nothing more to do. Then I'm going to say event.prevent default, and that'll prevent the enter from doing whatever the browser would want to do when you pressed enter, like submit a form or something. We're not submitting a form here. We're just trying to capture this message. So we prevent the default browser behavior. Then I'm going to say const text equals event.target.value.trim, and then I'm going to say if text length equals 0, then return. So if they just typed in whitespace characters or they did nothing, just do nothing. Like don't process this event handler any further. So make sure they actually typed in some text. And then should be pretty easy to guess what's going to come next. Simply Socket.emit chat::add, and then in an object, we're going to do message is text. You might be wondering why I'm creating objects out of this. We can actually pass in as many parameters as we want, and they can be of any type. So I could pass in just straight up text right into this chat ad. So why am I making an object out of it? Well, generally speaking, sometimes you might want to add additional metadata to your chat ad Socket.emit. And because that's such a common thing to do, I generally preemptively wrap these in objects instead of just passing in the string itself. So that's what I'm doing there. The final thing I want to do is say event target value equals empty. And of course, what that'll do is it'll clear out our text box. All right, so that is our text box. Let's jump back over to server.js. Let's come back over here and let's refresh. And now I can type in messages. I can say, hello world. And you see nothing looked like it happened, but if I open up this console window, you'll see the server did receive hello world. So blah, stuff, and things. All right. So now we have a problem. We're sending the data to the server, but the server isn't sending it back to us. So if I had multiple windows open here, nobody would see anybody typing. In fact, you're not even going to see yourself typing. I want to point out, sometimes it is considered to be better practice here when you're sending a chat message to preemptively add it to the chat list, so it looks like your chat message immediately arrived. We're not doing that in this case because that would just clutter up the example a little bit. But how do we go about handling when or having the server send back to everybody when a chat message is received? Well, let's come over to our server.js, and inside of our chat ad handler, remember, this handler is added for every socket that connects. So it's a new function, a new closure for every socket that it brings in. What I'm simply going to do is I'm going to say io.emit chat added data. So what's going on here? Well, I'm using the emit. Remember, emit is the thing that sends things out, and on is the thing that receives things. So I'm using emit. Notice how I'm doing io.emit. I'm not doing Socket.emit. Because socket represents that the person, the individual that connected. This will work, by the way, but it'll only send that data to that one guy who connected at that one time. So you'll only ever receive your own messages. You won't receive anybody else's. If instead I do io.emit, however, that sends it to everyone. That broadcasts it to every socket that's connected. And you can go and you can look at the docs to find out ways that you can actually create little groups and rooms where you can delineate who's logged in and only send messages to this list of people or that list of people. Or you could maintain an array of socket objects and only emit to the group that you want to. A million ways you can do it. But in this example, the simplest two things to do are to either emit data to the individual socket or emit data to everybody who's connected. And in this case, we're doing the latter. So how would we go about receiving this on the client end? Well, that's actually very straightforward. So what I'm going to do here is, I'll maybe collapse that line. That line was bugging me. I'm going to do something that should look familiar from the left-hand side. I'm going to say Socket.on chat added data goes into, and I'm going to say console log data. So now I'm doing Socket.on. Remember, this is the client code. This is the client socket that's running on the browser. When I do Socket.on, now I'm receiving or handling events that are sent from the server. So I'm receiving the added event, which I completely misspelled on the left-hand side, and I've now corrected. So I'm handling the added event on the right-hand side by simply using Socket.on. It's the same concept of what we did right here. It's no coincidence that these methods are named similarly, because they're very basically pretty much the same thing. It's just one's on the server, one's on the client. Anyway, let's jump back over into our client and let's refresh. And I'm going to go ahead and duplicate this tab to open up a different client. And I'm going to say, hey there. And I'm going to open up my console window on this client. And I'm going to see, check that out. Hey there was received by the server. But if I open up this different client and open up the console, hey there was received here. So let's open up these side by side. So now we have two clients connected to the same server. And I can say stuff and things. And notice how the server is sending it back to both clients. So both clients are connected to the Socket.io server through WebSockets, and now they're receiving both of those messages. All right, let's make this a little bit more interesting by actually having this print out to our chat list. So I'm going to say const chat list equals document.querySelector chat list ul. Make sure you get these periods in here because we're selecting on the element with the class of chat list. Sometimes it's kind of hard to see in the video that I'm using a class selector there. And then in chat add, I'm simply going to say const message element equals document dot create element li, and then I'm going to say message element inner text. Now I'm doing inner text and not inner HTML, because if I did inner HTML and the server broadcasted HTML code, we would have a cross-site scripting vulnerability. So whenever you do something like this, use inner text. It's available on all modern browsers, so be sure to do that. Inner text will not cause a cross-site scripting vulnerability, and I'll show you that in a second. I'll say inner text equals data.message, which is that object that we emitted out. And then I'm simply going to say chat list dot append child message element, and then I'm going to say chat list dot scroll top equals chat list dot scroll height, and that will scroll down to the last added element. So take a look at that code, because this pretty much completes the example. But take a look at that code, and I'll show you guys it working on the other screen. All right. So for this, I'm going to close my console windows. And I'm going to open up this guy. I'll put him up here. Open up this guy. Put him down here. Duplicate. Put another guy up there. Duplicate. Put another guy over here. I love Windows 10's grid-based thing. Let's go ahead and refresh all these guys. And let's type in a message. Hello, world. Stuff and things. So we can see that by typing this message down here, it's going to everyone. And if I type in so much that it starts to scroll, it always scrolls to the bottom. So now any of these chat clients can send this message. Blah, stuff, and things. Also, because I use the inner text property, there's no cross-site scripting. So I can't say script alert, hey. That will be properly, it's not even escaped. It's physically not even touching an HTML element. It's going into a text node, which is exactly the behavior we want. So we don't even have to worry about sanitizing our inputs as long as we never use inner HTML unless you absolutely know what you're doing. So again, that's a quick tip for anybody who's not familiar with that property. But there you go. Very straightforward. I know that, basically all we've seen here in this example is we've seen .on and .emit. And that's about it. We've used two whole methods, on and emit, excluding the setup code, two whole methods to work with Socket.io, and that's really all you need. But I wanted to do this simple example, again, to show you guys the basic use of Socket.io and how simple it can be. We are going to be expanding on Socket.io in this series and making it a little bit more cool. We're going to be integrating it with Reactive Extensions. It's going to be awesome. But I wanted to make it clear how straightforward and simple Socket.io was to you guys, so that when we go on, we build on top of this code, on top of Socket.io, things hopefully will make sense, and you'll understand the reasoning why I do things. Again, a couple things you didn't see an example of. You can pass in however many parameters you want into emit calls. So I could say, like, data arg2, arg3, arg4, and then on the other side I can pass in multiple parameters into that as well. However, we're not going to actually be doing that in the series, besides one thing, because of the way Reactive Extensions works, but wanted to point that out in case you guys were wondering. But that's it. That's it for Socket.io. That's it for Express. So it's time to actually build the application, and we'll see you guys in the next video.